Okay guys, so today is going to be the next one. In the previous video I have been uploaded about the AND gate and the NAND gate. Today it is going to be about the OR gate. In OR gate there are two inputs A and B, and the output is O. The Boolean mathematical form of the OR gate is O, which will represent output equals to A plus B, and both of them are input. The truth table of the OR gate is when both of the input are 0, so the output would be 0, and in the case when any of the input is 1 or both of the input are 1, so the output would be 1, which means the LED would get on. Moreover, in the simple mathematical form, when a is 1 is being added to 1, so it becomes 2, but it's a Boolean mathematical form, and in this, when 1 is being added to 1, so it becomes 1. So one should be careful about this while writing a truth table of the OR gate. In this experiment for the verification of the OR gate, that how for verification of the truth table of the OR gate, in this experiment the things which are going to be used are the wires, breadboard, OR gate, and the IC number of the OR gate is 7432, LEDs, and the most important is the voltage source. Okay, so starting, place the OR gate IC as shown. So we can place the OR gate anywhere in the breadboard. I can place this OR gate on the top of the at the top of the breadboard or at the bottom of the breadboard, depending on me where I want to place it. So it's not important that you have to place the IC right over here. I can place this IC at the top of the breadboard or at the bottom of the breadboard. Okay, here in the IC of the OR gate or all of the IC content, this one is being placed like this. This is a slice cut on the IC, and it should be placed like this, remember. So when the IC is being placed like this, so the top right side of the IC, this one is the positive side of the IC, and this one is basically the negative side of the IC. So before that, the first thing we are going to do is now insert a wire on the top at the right side of the IC. This is the right side, and it is the top of the IC with the positive side of the breadboard, which is this one. Now, as I've told you that this one there is one positive side and the other is a negative side in all of the IC. So this is one is the negative side. I am connecting this negative side with the negative side of the breadboard. Moreover, I can connect this one here also. This is also the negative side. But as I want to tell you that we can use anywhere these things. I can use this one column 2 and this one column 2 for the sake of convenience, and so I can use any side. I can use this one side too, I can use this one side too, depending upon me, so it doesn't matter. Now starting it, so the first thing we are going to do is now insert input AY at the top left side of the breadboard and insert it into the negative side of the breadboard. See, the yellow Y basically represents the first input, which is the A, and I'm inserting it in the negative side of the breadboard. This one represents the negative side of the breadboard, and I am placing it in the negative side of the breadboard. Now I'm going to place another wire which actually represents the input B, and I'm placing it. You see, this one is this one row, it's represents the output B, and I'm inserting a wire, silver color wire, and inserting this wire in the column or the negative column of the breadboard. Just see, it's the negative side of the breadboard. I'm placing this wire here. Actually, I'm going to prove the first condition of the OR gate, and that first condition of the OR gate was when both of the input are 0, so the output would be 0. Okay, then the next thing you are going to do is now insert another wire output X in the third row of the breadboard on the left side and leave it. Okay, now the next one, basically this one is, this one is input, this one is input, and third one is output. So I'm inserting a wire in the row of the output, but I will leave it as it. I will just insert here and I will leave it as it is. Now the placing the LED anywhere in the breadboard. Anywhere means anywhere. For example, I have placed this LED here. You can place it here, or here, right, anywhere in the breadboard, but it should not be placed in the rows of containing the IC. Without except these rows, you can place it anywhere in the breadboard. Where I have placed that LED in this side. Moreover, all of the LED they are basically contains a positive and negative side. Here the long one side, this is basically the positive, and this one is the negative, so one should be careful about while placing the LED. Okay, now the next thing that connective the negative side of the LED and breadboard with help of a wire. This one basically represents the negative side of the LED, and I'm connecting this the negative side of the LED with the negative side of the breadboard, which basically I'm giving a ground to the LED. Now insert the output wire with the positive side of the LED. The output wire, you see we have left that, and we have left that when we have inserted the wire in the output. Now we are inserting that output wire in the positive side of the LED, so the through which the truth table of the output can be verified. These are basically the close pick of the connection, so if one cannot see, so through this connection they can easily see the input. This one is input and this one is the output. This is the positive side which we have connected at the start, and this one is the negative side of the IC. This one is basically the output wire which have been connected with the positive side of the LED. Here there is LED, and this one is the negative side of the LED, and this is connected with the negative side of the breadboard. Another close pick, just see this one wire was the output, and I have connected this with the positive side of the LED, and this one is the negative, and this negative comes here with the negative, connected with the negative side of the breadboard. Now the voltage source is going to be required in this, because except the voltage source the LED won't work and the truth table cannot be verified. So for that purpose the voltage source is very much important. Okay, now see, I've connected the positive and the negative terminal of the battery with the positive and the negative side of the breadboard. I have used this one is a positive and this one is a negative, so I'm connecting this one via the positive here in the positive side of the breadboard, and this negative wire I have connected this in the negative side of the breadboard. Now you can see that the LED is off, but just see this yellow wire and the silver, both of them are being in the negative side of the breadboard, which means that both of the input are zero. And as I've told you, according to the truth table of the OR gate, when both of the input are zero, which means when the both of them are being connected with the negative side of the battery or the battery or the breadboard, so the output would be zero. And this is the first condition, and the first condition of the truth table is being verified through this, when both of the input are zero or being connected with the negative side of the breadboard or a battery source, so LED won't light up. And this is the proof of the first condition of the truth table of the OR gate. Now inserting the input A wire in the positive column of the breadboard, and LED gets on. See this one, the yellow wire, as I've told you, that represents the first input, that is A. Now I connect this with the positive side of the breadboard or the battery, and which means that I am giving it 1, and the other wire, this is basically 0, and the LED gets on, so which is verifying the second condition of the truth table of the OR gate. Now I'm just exchanging this for, I'm just giving the A, that is A wire, that's I'm giving it a 0, which means I'm connecting it with the negative side of the breadboard, and the silver wire, which is the output B, I'm connecting with the positive side of the breadboard, which means I'm giving it 1, so the output is 1, and as LED gets on, so it is proving that the output is 1. Now when both of the input gets 1, which means that the input A and the input B, both of them are connected with the positive side of the breadboard, so the LED is still on, which is proving the third condition, or the fourth and the last condition of the truth table of the OR gate, in which when both of the input are 1, which means when the both of the input are being connected with the positive side of the breadboard, so the LED would get on. Okay, now moreover, as I've in this IC, it's 7432 IC, there are basically 4 OR gates. This one, here is the gate, here is a gate, and here is a gate. I can use anywhere. For example, I in the previous you can see in the previous pictures, I have used the first OR gate, which is basically here. I have given two inputs at the top and the output at the third row of the IC. Now I can, if I going to use, for example, if someone is being interested in using the second gate present in the IC, so what you will do, you will just leave the first 3 rows of the IC and place the number A input wire in the 4th row of the IC, B input wire in the 5th row of the IC, and 6th and output wire you will insert in the 6th row of the IC, and the still and the LED and the OR gate will work as it was being used in the previous picture. You can see here I have used, so still if I I can verify the conditions, which means I can use AND gate, the OR gate, sorry, I can use OR gate, any of the OR gate placed in this IC. For example, I'm going to use this one OR gate, this one OR gate, this one OR gate, or this one OR gate, it will work the same. So all of the work depends upon, sometimes in the experiments more than one OR gate is being required. So for that purpose, I just want to tell you, for in the future, if one want to use more than one OR gates, so instead you are going to place more than one IC, use that one IC, and you can take help from that in using more than one OR gate, or at a time you can use 4 of the OR gate. So for that reason, I've just replaced this connection, and I'm using this gate number 2. Now in this connection, you can see I'm just now using gate number 3, the OR gate number 3. And this, the first one row represents the positive. I'm not going to use that one. The next one, this one is the input A, this one is the input B, and this one is the output O, and I'm going to use this one. And see, the LED is still on, which is verifying the fourth condition, and also it will verify the first and the second and the third condition also. So I'm not using these two gates, I'm using this one OR gate, this one OR gate, but still it's verifying the truth table, which is true that the IC contains for the OR gate, another OR gate also. Now see, I'm using the fourth and the last one OR gate in this IC7432, in which here is the last one OR gate in this input, and this one is output. See, both of them will be connected in the positive side, and this one is connected with the positive side of the LED, and still the LED is on, which is proving the truth table of the OR gate. So you can use any of the OR gate present in this IC. It's not important using this one gate. I can use this one, this one, this one. It's going to be according to my use or according to my choice. Okay, so thank you for watching. I hope this video will help you a lot while using the and doing the experiment. But please do like and subscribe my channel, Being Educated, for more interesting videos. Thank you for watching.